Okay, hi everyone, great to be here in this awesome conference, and thank you for attending this talk about GPU. I promise it will going to be interesting and practical. So let's get started. Nice to meet you. My name is Regev Golan, and I work at HiredScore for the past 3 years. At HiredScore, we are using artificial intelligence to make hiring efficient and fair for the Fortune 500. Previously to HiredScore, I was at the IDF in the Intelligence Corps for 6 years as a big data engineer, and I also have a bachelor's degree and now a master's for computer science. We are here to talk about the growing computing needs needed for AI. So the world is seeing artificial intelligence, deep learning, machine learning everywhere. There are so many startups and industries that rely on this exciting technology. This is just a picture of autonomous driving. And the thing about AI is that you hear a lot about GPU, Graphical Processing Unit. This is actually in that picture the Google's version of a GPU, the Tensor Processing Unit. And this specific hardware is designed to make artificial intelligence run faster. It uses parallel computing capabilities, which are thousands times more efficient than CPU for parallel processing. The thing is, you can't simply ask for a GPU, choose in your cloud provider a GPU instance and think it will all be okay. And this is the story I'm here to talk about, the HiredScore use case. So at HiredScore, some of the stuff we do is natural language processing. We basically have a document with a lot of text in it, and we need to extract entities and insights from the text to understand the words and sentences, and then to do all kinds of queries and processing on top of that. So it used to take us 20 seconds before we changed to work with GPU. And again, I'm not from NVIDIA, or I don't have any interest in that, just to share how we solved a technological challenge in our data science group, and for me as a DevOps for that project. So we knew that natural language processing might be better with using GPUs. So we started our journey in that path for the goal of lowering from 20 seconds per doc to much less, to be able to scale. And previously to that, we had many instances of that service also locally on a lot of servers, and wanted to narrow it down to have this capability of document processing as a service, and to be able to scale the organization and sales, support the sales. So as a DevOps engineer, you might think this is the Amazon instance page. So you go ahead and you want to choose a GPU instance, and you think this will be over with that. Suddenly you see this column over there, GPU memory. So wait, what does it mean? Another memory? I have my CPU, my RAM. What, will 16 gigs be enough? And then it gets even more complicated when you see that there are machines with multiple GPUs inside of them. So what should I choose? 4 machines of 1 GPU, 1 machine of 4. These are very expensive servers. It usually costs 10 times more as a normal EC2 instance. So this is the part when you need to understand that GPU and using this infrastructure, it means changes in the entire DevOps cycle. You need to develop differently, to operate it differently, to monitor, to release it. And this is what I'm here to talk about today, and the war stories we experienced when working with this infrastructure. So let's just go ahead and start talking about it. I want to immediately share our stack and what we have, what we are using. So using GPUs minimized the response time, the processing time for one document from 20 seconds to 1 second. It's a normal improvement when using this hardware. And we are using PyTorch, which is a Python library for working with GPU. We are using a model called BERT from Google. It's an open source. And the reason I'm mentioning that is because BERT is a very fat model. It supports 110 languages and have 170 million parameters. It's a very heavy and compute-intensive model. It assumes you will work with GPU. It doesn't make sense a lot to work with this size of model without a GPU. To deploy it in production, we are in the Amazon cloud and we use the Amazon Elastic Container Service. What is important to know, and I highly recommend to read online, there are a lot of good information about understanding the internals of the GPU. GPUs has basically, they are optimized for many parallel tasks, very simple parallel tasks, like a summary and multiplication of vectors, and they are highly relevant for deep neural networks because you need to do these actions in parallel or on a large amount of vectors and features. Also, one last point is the different types. I am mentioning only the GPU, the Graphical Processing Unit, but also there are the ASIC, the application-specific integrated circuit. These are like Google's TPU, a hardware designed for deep learning, as opposed to GPU, which is taken from the graphical and display world and was customized for deep learning, basically all the matrix multiplications. Also, there is the FPGA, which is relatively new. It's also a very efficient hardware, but it is not as flexible. So when you work with deep learning, I would say the main usage is GPU, but there are also these other types. I am using only the GPU as just as the topic, but there are other possibilities. I like to talk about history when I examining technology. So GPUs are not just a buzz or a trend. They are here and being used in deep learning for the past 10 years, since 2009, when two researchers from Stanford proved that deep learning can be highly accelerated using GPUs. In 2007, 2 years before that, NVIDIA released CUDA, which was the first programming model for GPU computing. Since then, there are many others, but CUDA is very widely used and known. So we are now starting to talk about the war stories, as I call them, and let's start with some code. We are engineers, we like to see code. So this is the hello world from PyTorch to use a GPU. And what I wanted to emphasize here, that using this specific framework, the programmer must be aware to the fact that there is a GPU underneath. It reminds us like the time where you should have thought about whether my CPU is 32 bits or 64. You actually need to load the data. This simple example, you take a vector of X numbers and you want to add ones to all of the vector. So you actually need to torch.ones like and load it to the device of the GPU. only then you are loading also another vector, and only after all the data was loaded from the RAM to the GPU's memory, and you pay for this memory shift. Then when you summarize the two vectors, you will get the improvement. And you will see the result in a very fast time. Memory is a big deal with working with GPUs. We saw errors that you tend to forget about them, segmentation fault and out of memory. These are two examples of issues. The right one there is a deep dive calculation about how many bytes will I use. I will need to take the model and the size of the input and how will I optimize it. And we spent a lot of time on this area. If you are just now start to work with GPUs, be sure to spare some time for this step. The memory management of GPU is not as convenient as the RAM. You don't have the swap space that can help if the memory gets too big. You don't have such a thing in GPU. It doesn't make sense because the GPU needs its own memory to be able to send it to the processing cores. You will need to be patient and have some time in debugging, both in production and in the research for this work. The second thing we stumble with, we work with big models. If you will now try to Google about that, you have like 5 gigabytes of a model that you have computed, and you now want to run the inference, the processing of the input of it in production. So Docker and containers are not that optimized to work in such a big size. You want your container to be as small as possible. And the thing to understand here, we used to have machines and have on them several containers. We are not aware about how many containers will be on that machine. In GPUs, it's different. Your codes need to be aware about how much memory will it have, and you need to plan for it. So, for instance, in the HiredScore case, we have a cluster of EC2s, just the minimum is 2 for highly available. We chose 1 GPU per instance just to make things simpler. We optimized our memory usage to be able to cope with only the 16 gigabytes of memory that 1 GPU machine has. And we are running 1 container per instance. This is an anti-pattern for containers again, but when you need a production inference deep learning service, this is what we chose. It makes things simpler and it does the job. It can scale to whatever the size and load we have, thanks to Amazon and ECS. And the model is packed inside the container. The containers becomes big. We have containers of 8 gigabytes, only the container itself, but it's working. And also when the service loads, it syncs the parts of the models that it doesn't have. We talk about microservices and monolith, and the real case is that our services are not so decoupled, and one service using a lot of models and doing a lot of work, and it's easier for the data science team to work like that. So you must be able as DevOps to also support that. So this is how we are running the stack, and it works great. But this was also an issue that needs to have some thought in it. I have 2 more points to talk about. monitoring. So this is the basic tool that our data science use when creating the models. They simply work locally on the servers with the NVIDIA SMI. You see here in the example that all 4 GPUs of that machine are utilized, and what are the processes that uses the memory. This is the default CLI tool from NVIDIA. Also, if you are running in production, you probably have some kind of Prometheus, so you can install the exporter to get those metrics. And in terms of what to monitor, so there are a lot of metrics to look at. GPU temperature, for instance, I found the most useful is simply the GPU and memory utilization, the top 10 operations, and the service metrics. By those, you can also scale your cluster and make sure you hold the stress you put against it. Talking about the cloud providers, so I thought that Google has a lot of provisioning and profiling tools for GPU. I feel that they are more advanced in that term. And Amazon has just recently announced on their own TPU instance type, which are optimized for deep learning, the infra. So worth checking out if you have the option to choose, worth checking out both. This is my advice. So just to one final point, when you have your application, it will work both on CPU and GPU. You want to take advantage of your money. GPU machines has also cores of CPU and memory in them, so you will need to take care of it, of that all. And also to be able to take out parts and place them on their own instances. One of the topics that we are also examining is having a GPU cloud and making a lot of services use a simple GPU deep learning inference, and then on top of that, doing their own calculations. So I don't have enough time to elaborate on that, but there are also many steps you can do to improve your efficiency. So to summarize, we've talked about those 4 short war stories, and the main point that I want to emphasize that it's literally one more exciting world in the area of DevOps when we feel that we are empowering the AI. It has a lot of impact to know and understand this unique hardware. That's it. I hope you enjoyed and have a beautiful day.